Hello. Hello and welcome to this video on C++ programming. So this was the program which we did in last video, and we had to force a const on this object A. So we will get rid of this const. So let's delete this const. That means we will need to delete this as well as this. Now if you see, you have got a red wavy line underscore this, and it says initial value of reference to non-const must be a null value. Okay. So left hand side is reference to a non-const. That is, our small a object is a non-const. And right hand side is not a null value. So if you remember from my C programming videos, an L value is something you can take an address of. Okay. So what the point is that, can we take address of this? So this A5, capital A5 is something you need to take address of, but it's a temporary. Okay, so it won't work. So what we need to do is we create this object A as a plain object, and then we create a reference B as like this. So here B is the reference of A. It is a non-const one, and then you do FB. So we will run this and see whether we get A here. Okay, and no, nothing happened. So we call G++. Okay, G++ is not in history. So we do G++ minus vol minus W error minus std is equal to C++ 26 minus pedantic function overloading .cpp. And then we run data out and we get 5 for both our calls of function f. So and then we talked about the function overloading stuff. In this video, we are going to talk about copy constructor. So let me create a different class here. Now this class will also do. Okay, so we have constructor, we have get a, fine. So what is copy constructor? A copy constructor is used to create copies. So suppose I have an object A, and I say that AB is equal to A. So here B is a copy of A. Why this way? No instance of constructor. Okay, I have to pass some value. So here B is a copy of A, and it is a creation of object B. So copy constructor will be invoked. But if you do B is equal to A here again, this will invoke assignment operator. Invokes assignment operator. And this invokes copy constructor. Okay, so there is that difference. Now, what is the syntax for copy constructor? So the copy constructor syntax goes like this: const, class name, and reference. Okay, or we better call it source. So usually your compiler provides a copy constructor. So you can say you want to use a default one, then you use default one. In many classes, it will work. The question is, for what classes will it work? So for our class A, it will work. The criteria is that you should not have dynamic values in your copy, in your what you call class. For example, if we have int star data, and let's say we have int b, and you say that in the constructor this arrow data is equal to new int b. Okay, So copy constructor by default will perform the shallow copy. So this data will not be copied properly by the copy constructor in its default version. So what you need to do is here this dot this arrow A is equal to source dot A, and then what you need to do is this arrow data is equal to source uh, not this new int, and then you say source dot pointer data. I forgot the correct syntax. Let's call it source dot data. It will give me correct syntax in a moment. Source dot data, and then we did first this. Okay. So all right. So this is what you need to do for your copy constructor. Now this constructor won't work. It should be some value. Okay. So now our copy constructor ensures that the data is properly copied to this copy. Now, once you have your dynamic values in constructor, you need to deallocate in the destructor as well. So you need to call delete on this arrow data. Otherwise, this will be a case of memory leak. Okay, this data will be leaked if you don't do that. So the other place where the copy constructor will be used is, suppose you have a function and you're calling this f, and the function goes like this: void f, and you'll see a. So at this moment also, if you pass by value, it will invoke a copy constructor. Okay. Now we can figure out why the signature contains a const reference. Okay. The reason of having a const is very easy, because we are going to only read it. And the reference is because if this is value, okay, then it will create another copy when you call it. When it will be called, it will create a copy, and then it will create another copy, and then another copy. So there will be an infinite recursion which will never end and will eventually crash the code. So that's why signature is like that. So let's see this. We try to run this. Okay. We will do another function. Let's call it void print numbers. Okay, and we do std. Do we have std? Okay, taken std out. Let's get, okay, iostream is here. Std out this arrow a, and counters this dot, or rather arrow data, or the numbers of this object. Okay, and we will just use backslash. Okay, so we run this, and then we invoke a dot print numbers, and we invoke b dot print numbers. We should see the same value. So like that, we run this, and then we do dot slash a dot out. Double free detected in the case 2. Okay, 5 and 10, double free. Okay. All right. So why it did it to double free? This arrow data. Okay, B is equal to A. Okay, so this is causing the problem because we don't have a proper assignment operator. There you go. All right. So this is how copy constructor works, and I have shown that, for example, you can invoke this print numbers here as well. and let's see that if this works. And yes, it works. So that is all about copy constructor. And I will end this video here because I like to keep videos short. And in the next video, what I will do is I will talk about R values and semantics of R values and how and where we can use it. One more thing is that you can overload constructors as well. Okay, let me show you. We talked about function overloading. So similarly, you can overload your constructors. This arrow data is equal to NP. And it might receive another message std string reference message. Okay, and we do std out message, and then we say std endl. Okay, so what we can do is we can make another object a1 and we call it with the message 5 comma 10 comma overloaded filter example. Okay, and this should work, and the constructor will print the message. Okay, so we compile this again, we run this, and we see the constructor call here. So in this constructor, there are three numbers we are passing, or three values we are passing. In this constructor, we are passing two. So constructors can also be overloaded like this. Okay. So with this, I will end this video here, and in the next video, we will talk about R values and why they are important, how they make the programs more efficient, and we'll talk about move constructors as well. There is another type of constructor which is called move constructor, and we will talk about std move, how it works, and what we can, how we can get performance improvements with the std move or move constructor. So thanks a lot for watching the video. I hope you have enjoyed and found it useful. So I'll see you in the next one after 4 days, because I have certain playlists: C++, JavaScript, Python, and Rust. These four rotate on a 4-day cycle. So C++ turn will come after 4 days, and I will come with a new video on the 4th day on R values and move constructors. So once again, I thank you for watching the video. I'll see you in the next one. Till then, keep programming and enjoy.